Let's talk about prediction intervals for new responses. So this is prediction intervals are different from confidence intervals. Remember, confidence intervals are used to make interval estimates about population parameters. Like, maybe we want to be 95% confident that the actual overall mean is between these two marks. Something like that. Now what we seek is some interval where we can say, I'm 95% sure that, if I make another observation that it's going to fall between these two marks. Some other observation you make may or may not be anywhere near the mean. Okay, so remember, by the central limit theorem, sample means tend to cluster right in around the population mean when the sample size is large. But actual, sample means of size 1, which are it's sort of the worst case scenario for means. Sample means of size 1, based on samples of size 1, are just single value observations, and they can tend to wander very far from the mean. Okay, so these are called prediction intervals. Okay, so it turns out that if x is, it takes on the value of xh, again h is for here, x is here, then what's the expected value of the actual y value there? It's beta naught plus beta 1 times xh. Just plug xh into the regression line equation. Okay, so this turns out that YH is normally distributed, conditioned on x being equal to h. Its mean is right along the actual regression line, which you'll never know, right? Remember, these betas are parameters. We estimate them with those b's. Okay, but anyway, here's how we make the interval, right here. Okay, it's our best guess for it, which is our the fitted value that you get when you sub in xh into your regression line equation, the b0 plus b1 times xh, plus a t value times the standard error. Okay, all of this is the margin of error. This is the standard error for the standard deviation for your observation value there at xh. So let's take a look at the used car data again. Why not? Making 95 and 98% prediction intervals for the price for a 4-year-old car. Now, I'm already assuming that these intervals should be wider than the confidence intervals, right? Confidence intervals should be tighter, smaller than the prediction intervals. I can, excuse me. There we go. Let's do that here. To do this, what I'm going to do is I'm just going to take the code from the notes there, and I'm going to get that standard error there. By the way, if you're not finished typing a bunch of stuff, in the argument of a function, you can hit enter, and R will sit and wait for it. You see how it starts with a plus sign there instead of that greater than sign. It says it's sort of indicating that it's waiting for more. It's waiting for more. I'm going to give it the rest of that statement there. So I'm just following the formula for the standard error there, right? This is at MSE times 1 plus 1 over n. All of that stuff is the square root of it. Okay, so then I can get my left and right interval endpoints by just subbing into the formula, right? Remember, the y hat there, I'm just plugging in my x value is 4 times b1, the slope, plus b0. That is, all of that stuff is my YH hat, right? I don't remember that is actually, that's the fitted value on the regression line that we got. So so now if I do LPT and RPT, okay, that gets me my left and right endpoints. Again, notice that since we're doing a 95% prediction interval, then these are 0.975s. Okay, and I can likewise I can get 98% intervals. Okay, of course they should be wider. Okay. Now you can do this real fast, however, with if you know the right R commands. What you can do is you put this in, and I'll explain it to you. Again, ND is as before. I'm going to set that to be some data frame. We don't really need it in this case because we're just looking about one age, but if I wanted to, I could look at multiple ages at a time and make a whole bunch of prediction intervals, and we'll do that coming up. But so here I use the predict function. Out is, I've already done my regression, my linear model, remember, and I stored it. I stored the output of that in out. Okay, comma. This data frame is just the number 4, really. Okay, but this time I'm going to stipulate that the interval type is prediction, not confidence. Okay, so it knows to make a prediction interval, and the confidence level is 95%, and there it is. The lower endpoint is 111.5243, and the upper endpoint is 189.3152, just what we got here. And I can make a 98% prediction interval thusly, and same as this.